Earth's interior. This diagram here represents Earth's interior. It's one way to look at it. Please, before we go on, just want to let you know, humans have only drilled down maybe that deep. We've never gone down there, we've never drilled down there. Everything we know about it is from how earthquake waves travel through Earth. Okay, that's how we know about the inner core, about the outer core, about the mantle. That's a key point I will need to make here. Page 10 of the reference table has the inner Earth section. I'm going to zoom in to this part of it because this is hard to see. So what you have here, you have the inner core, outer core, stiffer mantle, asthenosphere, crust, ridge, and mantle of the lithosphere. It shows the convection currents, and it shows densities here, which is really important. It shows the density ranges, so know that these are there if you need them, and definitely the information about the ocean crust and continental crust, what kind of rock it is, and the densities as well. That's on there. In addition, if you go back here, you could get the temperature and the pressure, any depths, if you trace them down to this line is the temperature line, this is the pressure line. Those are more obscure questions. They come up, but they're more obscure. So one thing I want to focus on is if you have an earthquake here, it is how P waves and S waves travel through Earth. Notice the P waves are solid, S wave are the dashed lines. So let's look at the P waves first. The green represents areas of Earth that will receive a P wave, okay? So a lot of Earth does, but some sections don't here. This gray area of Earth and gray area here don't receive P waves, and, well, why is that? So you see the P waves sort of are bent there, and they're bent there, they're bent, they're bent, they're bent. That is called refraction, okay? Refraction. And that happens to waves when they go into a material that has different density. And so that is how we know what the densities of these, the inner and outer core are. Now let's go on to the S wave part of it. And again, it's the dashed lines. And notice this is the section of Earth for this earthquake that will receive S waves. This whole area won't, okay? And therefore, when we go back and look at this, we know something about S waves. S waves do not travel through liquids. We can make S waves in a lab, and we can test it on liquid rock. And S waves, by their nature, don't travel through liquid. So because of this here, this is called the S wave shadow zone. And these are called the P wave shadow zone. This is how we know that the outer core must be liquid, because the S waves seem to just get absorbed or just stop there. That's important. And then what I drew on here is the S wave and the P wave together. So now this is the P wave shadow zone, as I said, these two areas here, and then all of this is the S wave shadow zone. Important element about inner Earth.